Imagine for a second, what if all the light in the world just disappeared? Right now, you wouldn't just be in the dark. No, you wouldn't even be able to see your own hands in front of your face. So what is it that actually pulls our world out of that complete and total darkness? What is it that makes anything visible? You might think, well, maybe objects just have their own light, right? Or is there something else going on? Something much, much bigger? To figure that out, we have to peel back a fundamental layer of how reality works. This is the science of light, and we're diving right in. You know, seeing is something we do every single second, so we almost never stop to think about how it actually works. But it turns out it's this really cool 3-step dance. Okay, so first you need a source, like the sun or just a lamp. It shoots out light. Second, that light zips across the room and hits an object, let's say an apple. And third, this is the absolute key. The light bounces off that apple and goes straight into your eyes. Your brain gets that signal and boom, you see the apple. So here's the crazy part. You're not actually seeing the apple. You're seeing the light that bounced off of it. So how does that light get from the lamp to the apple to your eye? Well, it follows one very, very simple rule. It always travels in a perfectly straight line. In physics, we actually have a name for this. It's called ray optics. We just pretend that light is made up of these super thin straight lines called rays. And this simple idea, it's incredibly powerful. It's the foundation for, well, pretty much everything we're about to get into. All right, so we see things because light bounces off them. But is it just chaos? Does light bounce around randomly? Nope. There are rules. And that brings us to the heart of it all, the law of reflection. And what's awesome is how simple this is. Just think about throwing a rubber ball straight at a wall. It doesn't just stop, right? It bounces back. Well, light does exactly the same thing when it hits a nice, smooth surface. That bouncing back is what we call reflection. Now, to really get a grip on this, we need to meet the 3 main characters in this story. The light ray that comes in and hits the surface, that's the incident ray. The one that bounces off, that's the reflected ray. And to measure all this, we draw an imaginary line straight out from the surface at a 90-degree angle right where the light hits. We call that line the normal. Now, these 3 lines always follow 2 very simple laws. First, and this is the big one, the angle that the light comes in at, the angle of incidence, is always exactly equal to the angle that it leaves at. And second, all 3 of them, the incoming ray, the normal, and the outgoing ray, they all lie on the same perfectly flat surface. So let's burn this into our brains. Angle in equals angle out. Simple as that. This one little equation is the secret sauce behind every single mirror you have ever looked into. It's perfect, predictable, and it never breaks the rule. So how does that one little rule create the perfect, crisp image of you that you see in the mirror every morning? Let's break down what's happening when you look into a regular flat mirror. The image you see has 4 very specific qualities. It's erect, which just means it's upright, you're not upside down. It's the same size as you. It's laterally inverted, which is that weird thing where your left hand is your reflection's right hand. And the most interesting one, the image is virtual. So what on earth does virtual mean? Well, it means the image isn't actually there. It's not physically located behind the glass. The light rays just look like they're coming from that spot. Your brain is basically being tricked. It sees the reflected rays and traces them back in a straight line to a point where it thinks they started. It's a clever illusion. Okay, but this raises a really good question. If everything we see is just reflected light, then why isn't everything a mirror? I mean, think about it. Why can you see a perfect reflection in a mirror, but not in the painted wall right next to it? Both of them are reflecting light, right? So what gives? The whole secret is texture. See, a mirror is ridiculously smooth. So when a neat, orderly beam of parallel light rays hits it, they all bounce off in the same organized direction. That's regular reflection, and it preserves the image. But a wall, on a microscopic level, it's a mess, all bumpy and uneven. So when those same parallel rays hit it, they scatter in a million different directions. That's called diffused reflection. It lets us see the wall's color, but it completely destroys any hope of a clear image. Now, so far, we've kept things simple. We've only been talking about perfectly flat mirrors, but the world isn't always flat. So what happens if the mirror itself starts to bend? Well, when the surface starts to curve, the laws of reflection don't change, but the images they create, oh, they start to warp and twist in some pretty wild ways. Suddenly, your reflection can be stretched tall, squished wide, or even flipped completely upside down. In the next part, we're diving deep into the world of spherical mirrors. We're talking about the science behind everything from funhouse mirrors to massive space telescopes. And that, my friends, is where the physics gets really, really powerful.